All right, here we go. I've given you a graph, and in this graph, we are told that we've got the diver's position. So some diver's position in meters, diving pretty high height, and we'll go over that in a second, at any time t measured in seconds. So the x-axis is in seconds. It's the time the diver's been in the air, and s of t is the position the diver is at in meters. So basically the diver's height off of the ground or the water. So in part A, the height from which the diver jumps, that's what we need to estimate. Well, what's the height from which the diver jumps? If we take a look at this, that's going to be at time t equals 0. So that's called s of t. So essentially we want s of 0. And we could estimate that, although I'm thinking it's pretty exact. S of 0 is this value right here. And that's going to be equal to 10. And now we need to have units, meters. So that's the initial position of the diver. The time at which the diver hits the water, well, that would be when the height is 0, right? So that would be when s of t is equal to 0. And that happens at approximately, well, let's take a look at the graph. Well, each of these boxes goes up by 1, 2, 3, 4, 5, between 0.5 and that. So that's 0.1 seconds. So this would be 1.6, 1.7, about 1.8, roughly. So about 1.8 seconds. Got to have those units. The velocity the instant the diver enters the water. This is going to be more of an approximation. I'll do this in a different color. So you want, at this point, the slope of the tangent line right there, right? So that's what you want at that instant. And so what is the slope at that instant? I don't know. That's going to be a tough approximation. If we extend that out, it looks like it goes back and up about 2. So it's steeper than 1. So we're going right 1 down 2. Like if you were to extend the line out here, roughly, right 1 down 2. So remember, you've got that velocity that we need there. So this would be s prime of, well, 1.8, roughly. So s prime of 1.8, which is equal to the velocity at 1.8. You could say that notation there, which is approximately -2 meters per second, right? Rise over run in terms of units, meters per second. Not bad. And it's negative because, of course, the diver's going down. The time at which the diver's velocity is 0. So that would be, where is the slope? 0. Well, let's take a look at this graph. Well, the slopes are all positive here, right there, right about there. The slope is 0. We have a horizontal tangent line. We've heard of that before. Interesting. And then the slopes all go negative. Interesting indeed. So roughly, what is that time? That's roughly at about 0.6, right? Here's 0.5 over 0.1 more, so 0.6. So that would be at approximately 0.6 seconds. Need the units again. Do you notice? So what do you notice is also true at this time? Well, it's the maximum height. So that's the max height of the diver. Interesting. We're going to be going over that more in a later chapter, but think about it. The diver's velocity is changing from going upwards, stopping instantaneously. You go to the top, you stop, and then you start falling down faster and faster. So your maximum would be where your velocity changes from positive to negative. Interesting. Last but certainly not least, we're going to sketch the velocity and acceleration graphs of s of t. In other words, you're going to sketch the graph of s prime of t, and then I'll do it in a different color. I'll do it in orange. You'll sketch the graph of s double prime of t. We'll get to how to do that in a second. So how do we do this? Well, to sketch the velocity graph, what we're going to do is remember from our training in a previous section where we went from f to f prime graphs, that the velocities on this, or the slopes of s of t, are the y values on s prime. So we've got positive slopes, 0, and then we go negative. So, first of all, we've got to sketch it from here to here because our time is only positive. And we start out positive and then go negative before hitting 0 somewhere at about 0.6. So here's 0.5, here's 1, and then here's 1.5. We've got to make sure we hit this pretty well. So we're going to have a velocity of 0. Remember, the y value on this curve is the slope on that curve. We're going to be positive everywhere before that. Okay, so that's a line going down to here. This is the only kind of curve I know that goes from positive to negative. And then we're going to go negative because all our slopes are negative after that. So it keeps going down until it stops right around, I would say, 1.8. So I'll put a dot down there. And we just continue the line down to there. Beautiful. Beautiful. Now, as for the acceleration curve, you now take this and you use only that to graph your acceleration curve. No longer are we using this. Now, the acceleration is the derivative of velocity. So the slopes on this graph, on s prime, are the y values on s double prime. So what we're going to do is we're going to notice that our slope is negative the entire time and it's constant. So we have a negative y value the entire time and it is constant. And I should stop the curve when we get to the end here, roughly right about there. That's it. Oh, that was fun. That was real fun. I will see you on the flip side.